Hello, let me welcome you today as well, as we want to proceed with the topic we started previous week, exponential and logarithmic equations. Mwantagizwa ndine Sister Juma. Just a quick review of what we did the past week. We looked at exponential, the definition of exponential. Please go back and revise the video and watch the video again. Then we expressed the numbers as powers of a given base. Please go check the video. Then we looked at some examples. So today I would like us to do the actual solving of exponential equation. Mutakumbukira bwino lomwe kuti equation can be defined as an algebraic expression with the left hand side equal to the right hand side. Tikakambaza equation vidalesa kwenza kuti left hand side commercial can right hand side. Most left hand side in expression which is equated to the right hand side. Okay. On the other hand, an exponential equation immediately now last time. It's an equation in which an exponent or index is unknown. Okay, by now you should know tikanena kuti index ndi chani, tikanena kuti exponent ndi chani, tikanena kuti power ndi chani. Mawu amenewo are being used interchangeably. You have to know them. For you to know them, go back to the previous video and watch. And our main duty now is solving now those exponential equations, whereby our main duty will be to find the value of the exponent, to find the value of the power. Okay? In this case, aninoni simakhala base, aninoni makhala power. So what we are going to be doing is to make sure that the power the power which is unknown has to be found. So let's look at these examples. These are examples of an exponential equation. Last time, that's a base, and this is a power. This is the left hand side of an equation. That's the right hand side of an equation. Okay, the same here. That's the base. 2 is the base. That x there is the power. If you look at it, the x is unknown. Okay, which means our power is unknown. Our index is unknown. Our exponent is unknown. So, we should find that unknown. The same applies there. We have 4, and our power is x plus 2. Is equal to 64 power 2x minus 2 minus 1. So, this is the base, and that is the power. That's not the base, that is the power. Okay, so our main duty today is to make sure that we find the value of that exponent, find the value of that power which is unknown. Let's look at them one by one. Okay, so for us to solve these ones, for us to do that, to solve to find the value of that unknown, okay, we are going to demonstrate as we are going to solve those examples. Okay, so to solve exponential equations, we are saying firstly you need to express the left hand side, okay, This is the left-hand side. Okay, let me just take this out. This is the left-hand side. Has to be expressed to have the same base. Okay, the left-hand side and the right-hand side have to have the same base. Okay, so you look at your equation. That's the left-hand side, that's the right-hand side. You need to make this right-hand side to have the same base as that left-hand side. Okay, how to transform numbers into a base of a given number? We demonstrated that during our previous video. Please go and watch. Of course, we are going to show it here, but it's good to go and review it. So those are our rules. You make sure left hand and right hand side of the equation must have the same base. Then after having the same base, you need to equate the indices. Indice is the same as to say power or exponent. So they need now to be equated. Okay. Pamene mwampanga 27 kukhala base 3. So you need to equate my powers now. Pamene my base. Okay. Let's look at examples. We have this one as our equation, and this is our left-hand side of this equation. Excuse me. And that is our right-hand side of our equation. So the first rule is to express the left-hand side and the right-hand side bases to be the same. Okay? So in this case, since this one is the lowest, we are going to make that one to be base 3. Okay? So we are going to, now we are solving, change 27 to base 3. Okay? Change 27 to base 3. 27 to base 3. How do we do that? Tunaona itsameri mabangira sabatayata. Sorry. Yeah. 27 to base 3. Okay. 3 into 27. That's 9. 3 into 9. That's 3. 3 into 3. That's 1. Okay. So the same as to say 3 to the power 3. Okay. That's how we do. We change a number to a certain base. So 27 is the same as to say 3 to the power 3. Okay. Therefore, we can rewrite that as 3 to the power 2x is equal to 3 to the power 3. Okay. Then the second row is to equate indices or power. Equate them. Okay. So that's the base, that's the base, that's the power, that's the power. So our power is 2x on the left hand side, which is equal to, on the right hand side, our power is 3, which means x will be equal to 3 over 2. Yeah, that's good, that's that. Let's proceed. On this one, we do the same. Yeah, so we have that. The left hand side, we have 2 to the power x, and the right hand side, we have 0.0625. Okay, before we proceed with this one, we need to write this number to base 2. Okay, so how do we do that? Last week we showed. I also showed here the way we do it. Okay. So we are going to express. First of all, I have to express. We have to express 0.0625 to, oh my god, to, we have to express as, let's express it as, this is 5, as a proper fraction. Let's express that as a proper fraction. Okay, so how do we do it? Simple. You just multiply it by, let's just multiply it by 10,000. You find out that you have 625. Okay, 0.0. You multiply this one by 10,000. Okay, 1, 2, 3, 4. 4 zeros. We are going to multiply by 4 zeros. 1, 2, 3, 4. But we don't want to change anything. We are going to divide by 10,000 as well. So if you multiply this way, over 1. If you multiply the numerators, you have 625 over, in this case, 10,000. Okay. Yeah. So if you simplify that, you will find out that 625 to be equal to 1 over 16. Okay, let's show it. 625 into 625, we know it's 1. 625 into 10,000. So let's have 10 to 4, yeah, 10,000 divided by 625. You have the answer 16. Yeah, so it's 1 over 16. Okay. Then we are going to simplify the fraction. We have simplified that fraction. Then let's change to base 2. Change. Now 1 over 16 to base 2 for us to have that base. Okay, so in this case, we know that, let's see, look at it, we have 16. If we put 16 to base 2, it will be 2, that's 8, 2, that's 4, 2, that's 2, 2, that's 1. So it will be 1, 2, 3, 4. So 16 is the same as to say 2 to the power 4. Okay. So change 1 over 16 to base 2. We have as 1 over 2 to the power 4. Okay. That's 1 over 16, which is equal to, okay, let's put 1 over 16, which is equal to 1 over 2 to the power 4. We have shown that. And this one, excuse me, this one is the same as to say 2 to the power negative 4. I expressed this last time. So go and see how we did that. But that's that. Okay? Then we know now that 2x, instead of putting 0.00625, we know we have transformed that one into that, which is power 4. So we are going to equate powers or indices or exponent. In this case it will be x will be equal to minus 4. Okay. Yeah, so now to be done, we have that our last example. In this case, tabatsidwa moteromo kuti 4 to the power x plus 2 and 64 to the power 2x minus 1. Okay, if it is possible to make 64 into base 4, we can make it. If it is not, then it means we have to make the left hand side, it has to have the smallest base, which can be 2 to the power 2. Okay, base 2 and to the power 2 is the same as 4. Okay, yeah, so but in this case we'll try to see 64 if it can be expressed to base 4. So let's try change 64 to base 4. Okay, Chayamba said make the bases on the left hand side, on the right hand side to be equal. If the bases are equal, it means the powers have also to be equal. Yeah. Okay, so we are going to change 64 to base 4. How do we do that? We had shown that. I also do it here. Okay, so 4 into 64, that's 1. Okay, 64 divided by 4. Yeah, that's 16. 4 into 16, 16 divided by 4, that's 4. Then 4 into 4, that's 1. Okay, remainder 1. So you have 4 to the power 3. Okay, so Abu Bambari. So therefore, we'll say that 64 is equal to 4 to the power 3. Okay, then let us rewrite. We'll have 4x plus 2. It's good to put brackets. Equal to 64. Instead of putting 64, we are going to put 4 to the power 3. Okay, that one should be multiplied by 2x minus 1. Okay, so this one can be written as 4 to the power x plus 2 is equal to 4 to the power, let's expand that, 3 times 2x, that's 6x minus 3. Okay, yeah. Then reaching that far, we are now safe. We can equate the powers. Therefore, equate powers. Okay, so on the left hand side we have x plus 2. On the right hand side we have 6x minus 3. So put like term together, you have x plus okay, yeah, x plus 6x, which is equal to x plus x, yeah, so yeah, so it will be 2 plus 3. Okay, putting like term together. So sorry. Let's do it again. Let's put it as 6x minus 3 to be equal to x plus 2. If x comes this side, it will be negative. It will be 6x minus x. 3 will be 2 plus 3. So 6x minus x, you have 5x, which is equal to 5. And x will be equal to 5 over 5, which is equal to 1. So that's the value of your x. Okay, so that's the value of x. Reaching that far for today, I think we should stop there. Here is the take-home exercise. Please try to practice that. If you don't understand, you can always reach out. Thank you. Have a good week.